So, about this debate on serverless versus containerized workload, I think one of the biggest differences is in deployment flexibility. With serverless, you don't have to manage the underlying infrastructure, which can be a huge advantage.
Yeah, but it's like choosing between a bike and a car for every trip. Sometimes, you just need that extra control.
True, but with containers, you get more control over the environment, sure. But setting up and maintaining those environments can become quite cumbersome. Imagine having to configure everything from scratch each time.
And then there's the fun of scaling during unexpected traffic spikes. It's like trying to predict when your friends will suddenly show up for dinner.
Exactly. In serverless architectures, autoscaling is much easier because you only pay for what you use. Plus, the operational overhead is significantly reduced since cloud providers handle most of the management tasks. Speaking of autoscaling, let's talk about the cost implications. In a serverless architecture, you only pay for the compute time you consume. That means no idle costs when your functions aren't running.
But what happens when you hit those unpredictable spikes? You could end up paying more than expected if you're not careful with how your functions are invoked.
Absolutely. With container-based architectures, you might have more predictable pricing, since you're typically charged based on the resources allocated over a period of time. However, you still need to provision enough capacity to handle peak loads, which can lead to over-provisioning and wasted resources.
It's like renting a house or just booking rooms as needed. The house gives you stability but at a fixed cost, while booking rooms is flexible but can get expensive quickly if everyone shows up at once.
Precisely. The trade-off is between the flexibility and potential cost savings of serverless versus the control and predictability of container-based solution. Each has its own set of advantages depending on the workload and budget constraints.
Definitely a case-by-case decision. Sometimes it feels like choosing between a buffet and a la carte menu. Both have their perks, right?
Right, and understanding your specific needs and usage patterns is key to making the best choice. The sea breeze here reminds me that both options have their high tides and low tides in terms of costs and benefits. Speaking of which, let's consider the development workflows. When using serverless functions, developers often focus purely on writing the function logic without worrying about the underlying infrastructure.
That's true, but it can also feel a bit restrictive. You have to adhere to certain paradigms and limitations imposed by the serverless platform.
Yes, but that can actually streamline the process. With fewer decisions to make regarding infrastructure, teams can iterate faster and deploy changes more efficiently. Plus, you get built-in features like monitoring and logging out of the box.
On the flip side, with containers, you have a lot more control over your environment. You can package your application along with all its dependencies into a container image, ensuring consistency across different stages of development and production.
Exactly. This approach provides a high degree of portability and reproducibility. However, it does require more effort in managing Docker files, orchestrators like Kubernetes, and maintaining those environments consistently.
It's almost like comparing coding in a fully featured IDE versus writing scripts in a text editor. One gives you lots of tools at your fingertips, while the other lets you build exactly what you want from scratch.
True, and both approaches have their merits, depending on the project's complexity and team preferences. The key is aligning the workflow with the project's goals and constraints. Another interesting aspect is state management. In serverless computing, maintaining state across function invocations can be challenging, because each invocation is stateless by design.
Yeah, it's like trying to keep track of a game when you start fresh every time you play. You have to rely on external storage mechanisms like databases or caches.
Exactly. This adds complexity and potential latency, especially if your functions need to frequently read and write state information. With containers, you can maintain state within the container itself, which can simplify things and reduce latency.
But then again, managing state in containers means dealing with the overhead of ensuring consistency and synchronization across multiple instances.
True. Well, containers provide more flexibility in handling state internally, but they also require careful consideration of how data is shared and synchronized between different instances. It's a trade-off between simplicity in serverless and more granular control in container solutions.
Kind of like choosing between a centralized kitchen where everything is managed for you versus cooking at home where you have full control but must manage everything yourself.
Precisely. Each approach has its own set of challenges that need to be addressed based on the specific requirements of the application. Speaking of which, let's talk about latency considerations, especially in real-time applications. With serverless functions, cold starts can introduce significant delays as the function initializes.
Oh, those cold starts are like waiting for a bus that always comes late. You never know when it will start up and be ready to go.
Exactly. Persistent containers, on the other hand, are always running and ready to handle requests immediately. This reduces latency significantly, making them ideal for real-time applications where response times are critical.
But then you have to balance that with the ongoing resource usage of keeping those containers active. It's like having a car idling versus calling an Uber whenever you need it.
Right. Persistent containers offer lower latency, but at the cost of continuous resource consumption. Serverless functions can be more efficient in terms of resource utilization, but may suffer from higher latency due to initialization delays.
And it would depends on the nature of the application, whether you need consistent low latency or can tolerate some variability in response times.
Absolutely. Real-time applications might lean towards persistent containers for their reliability and low latency, while others might prefer the scalability and efficiency of serverless, despite the potential for higher initial latency.